Welcome back. On our lesson today, we're going to be learning about solving systems of inequalities by graphing. This section is going to be very similar to a combination of sections that we've done. Our learning targets for this lesson are to be able to solve systems of inequalities by graphing, and then also to be able to find the coordinates of the vertices that are formed when we graph our systems of inequalities. So first of all, when we graph the systems of inequalities, we're basically just going to be graphing the lines, the boundary lines, whether they're dotted or solid, and then shading the appropriate side of that line. And since we have two or more inequalities, the overlap or the intersection of those solutions, those shaded areas, those will represent the solutions to the system of inequalities. So the first step is to graph all of the boundary lines and shade the appropriate boundary lines, and then in some way to show where the overlap or the intersection of those boundaries are, and those are all the solutions that are included. So for this first inequality, it's in slope-intercept form, so if you just graph the line, this will be a dotted line because it does not have equal to. The y-intercept is 4, the slope is -2, so graph your y-intercept, and then use your slope for another point. And likewise do the same thing with the second inequality. This one crosses the y-axis at -2, has a slope of +1, and I've went ahead and drew those in here for you. So the red dotted line represents the first inequality, the blue solid line is the second inequality. And I've shaded the two regions. The intersection of those two regions is indicated in green. So those are the solutions to the system of inequalities. So here's another example for you. It says to solve the system, and we have y is greater than x plus 1, and then the absolute value of y is less than or equal to 3. Now this one I wanted to do with you simply because this absolute value of y is different than what we've looked at before with absolute values. All of the absolute values that we've graphed before have given us a V-shaped, and that's because we had an x and a y variable. Now this one is just the y variable, so the absolute value here, we can write that as two inequalities, and I have that in here in your notes. We can write that as y is less than or equal to 3, and, so that's the intersection or the area between that one, and y is greater than or equal to -3. So we do those two scenarios here, and then we also have the y greater than x plus 1. This one has a y-intercept of 1 and a slope of 1. If we graph those, here are our two horizontal lines from our absolute value, and then in between those two lines is the shaded area, less than +3 but greater than -3. But then we have our other boundary line, which is y greater than x plus 1, crosses at +1, has a +1 slope. That is dotted, and the intersection of those three different lines is this kind of a butterscotch colored shaded region. So those are all the solutions. There's another example below, solve the system. In this one, if you look at your inequalities, you can tell that we have the same slope. So right away we know that the lines are parallel, but we still need to go ahead and graph those because sometimes it might be the area between them. But this first one, it says that y is greater than those values, so that's the area above and to the left. And the second one is less than, so that's below. So these do not have any overlap or any intersection points, so this one is no solution. Now keep in mind that if we had switched these where the first one was less than and the second one was greater than, then we would have a solution. So don't think just because they're parallel that there are no solutions. You still need to graph those and take a look at what area is shaded. So be real careful with those. So here's an example where we're going to find the vertices of a polygon that's created by these boundary lines. And so the first example here, it says find the coordinates of the vertices of the figure formed by these three inequalities. So first of all, we're going to graph and shade each of those inequalities, and then we're going to find that intersection. And I've told you that forms a triangle. So I would put each of these in slope-intercept form, and the toughest one to graph is going to be this third one. So this one we would have y is greater than or equal to negative x minus 1, so it crosses at negative 1 and has a negative 1 slope. This one would give us y is greater than or equal to x minus 6, so it'll cross at negative 6, and it will have a positive 1 slope. And then this last one here, this is the one that's going to be tough. Not a real good way to graph this one easily, but I'll just show you what the solution looks like. And I won't give you one quite that difficult on any kind of a test or anything. I'll give you ones that graph pretty easily. So these are all graphed here for you. The negative 1 slope is right here, so that represents the first inequality, crosses at negative 1 right here. The second inequality crosses at negative 6 down here, so that's this line right here. These are all solid lines. And then the top line here is the 12y plus x less than or equal to 32. So it's real easy if you graph carefully. These two crossed exactly on a point, so we can get those two vertices easily enough. But the vertex down here is not so easy to figure out because it's kind of in the middle of a box. So we don't know what those coordinates are. So what we're going to do is we're going to take the inequalities that give us that point. So we're going to use the 12, wait a second, I'm telling you the wrong one. We're going to use the other two. The first two are the two lines that intersect to give us that point. So we need to solve those algebraically. So now you know why we did the sections on solving algebraically before we got to this section. So these two inequalities, actually we're just going to solve the equation so we can figure out what those values are. So when I add those together, I get 2x is 5, or x is 5 halves. Plug it back into the first equation for x, and then we end up with y equals negative 7 halves. So that last vertex is 5 halves and negative 7 halves, and the other two vertices I've listed for you as well. So that, in a nutshell, is how we are going to find these shaded regions, or the combination overlap of solutions that satisfy all of our inequalities. So a lot of practice on graphing. That'll do it for this video. See you in class.